Welcome to Oryx Learning. Today's lesson is on Unit 1, Real Numbers, Lesson 10, Compare Real Numbers. So here we have the statement, all square roots are irrational numbers. Change my mind. So as we go through this lesson, we want to see, are all square roots irrational numbers, or can we change his mind? Real numbers can be broken up into several groups. First, rational versus irrational. Remember that a rational number can be written as a comparison of two integers. Irrational numbers cannot. So in other words, rational numbers can be written as a fraction, like 1/2, 0.4 repeating, 0.45, 18%, or -3/4. Irrational numbers would be numbers like pi, e, or the square root of 3. Rational numbers can be broken up further into integers, whole numbers, and natural numbers. Integers are our number line numbers, such as -3, -2, 0, 1, 2. Whole numbers are 0, and our positive integers are counting numbers, so 0, 1, 2, 3, etc. And the natural numbers are just the positive whole numbers, not including 0. So they would start with 1, and then go 1, 2, 3, etc. You can compare and order real numbers by writing them in the same notation. Write the numbers in decimal notation before comparing or ordering them. For example, if I would like to compare the square root of 5 with 2.35, it would be easiest to change the square root of 5 to a decimal. So the square root of 5 is approximately 2.24. Now that both the numbers are in decimal form, it is very easy to see that 2.24 is less than 2.35. Therefore, the square root of 5 is less than 2.35. Select all of the categories that the number -5/8 belongs to. So -5/8 is a fraction. A number that is a fraction is a rational number. It is not a whole number or its opposite, so it cannot be an integer or a natural number. And if it's rational, it cannot be irrational. Therefore, our only option in this case is a rational number. Our next example, write the fraction 2 3/4 as a decimal. In order to write a fraction as a decimal, divide the fraction part of the mixed number using long division. So in this case, I'm going to take 3 divided by 4, as shown here, to get 0.75. Next, I want to add on the whole number. So 2 plus the 0.75 would give me 2.75. So 2 3/4 is 2.75 as a decimal. Fill in the blank with one of the following symbols, less than, greater than, or equal to, and compare the square root of 20 with 5.75. So here we see the square root of 20 is approximately 4.47. Remember that numbers are easiest to compare when they're decimals. So if I want to compare 4.47 with 5.75, I can see that 4 is less than 5, so the square root of 20 would be less than 5.75. Place the following numbers in order from least to greatest. So we have -4.6, -25/4, 40%, and 0. Once again, when comparing numbers, it's easiest if they're all in the same form, in this case, decimal form. So -4.6 is already in a decimal form. -25 divided by 4, using our long division, is -6.25. 40% means 40 out of 100, or 40 over 100, which is 0.40, and 0 is also in decimal form. So comparing these four numbers, the smallest value is that -6.25, which represents -25/4. Next would be -4.6, then 0, and then our 0.4 or 40%. The height of an oak tree was estimated by a calculation to be 45 plus the square root of 7m. When an actual tree was measured, its height was 50 meters, 50m. Which height is greater, the estimate or the measurement? Again, if we change both numbers over to decimals, they'll be much easier to compare. So let's start with the square root of 7. The square root of 7 is 2.65. Adding that on to the 45, 45 plus 2.65 gives us a total height of 47.65 meters. Comparing that to 50 meters, we can see that 47.65 is less than 50 meters. Therefore, the actual measurement is greater. Now that we're through the lesson, let's go back to this question. All square roots are irrational numbers. So although many square roots are irrational numbers, not all square roots are irrational. Square roots of perfect squares are always rational numbers. So our perfect squares are numbers like 4, 9, 16, and 25. And I will use 4 for my example. So the square root of 4 is 2, and 2 is certainly a rational number. So the statement all square roots are irrational numbers is false. In conclusion, you can compare and order real numbers by writing them in the same notation. Write the numbers in decimal notation before comparing or ordering them. Remember, it's easier to compare apples to apples than it is apples to oranges. So that is our lesson on comparing numbers. I hope you enjoyed,